So we're on part 2 of section 4.5. And we're still graphing sine and cosine functions. So to recap what we did, what we talked about on Friday, if we have a sine or a cosine function, y equals sine x. If we have nothing done to it, our period was 2 pi, and this was same for y equals cosine x. Oh no, that was just my bullet point. That was supposed to be a bullet point. So for both of these functions, the period's 2 pi. That means it repeats a full cycle in 2 pi units. The range is -1 to 1. So this is our basic, nothing done to our functions. And then we talked about a couple of transformations, a couple of changes that we make to our function. So the ones we talked about on Friday, if we put everything together, y equals a sine bx and y equals a cosine bx are the ones that we talked about. For these, the a, this number out in front, changes the amplitude. That changes how high or how low our function goes. So we said the amplitude is the absolute value of a. So we could put a negative number in here, in front here, and that would not only change the amplitude. What does a negative in front of our function do to the function? If we had y equals x squared, and then we graph that, and we also graph y equals reflects over the x-axis. So if I had a negative sign rather than a negative in front of the a, if a was negative, rather than the sign going up from 0, it would go down towards the negatives from 0. So it would flip it over the x-axis, just like it does for any other, just like that would do for any other function. So the amplitude is the absolute value of a. That tells us how high or low our function is going. If we're not shifting it at all, it tells us how high above 0 it goes and how high below 0 it goes. The other way we can figure out a, just a little shortcut, if we have a function that's graphed like this, if we look between here and here, between the maximum and minimum, that distance is going to be 2a. So from the maximum to the minimum is twice the amplitude. We said the amplitude was how far it goes above the 0 or the, what we call the equilibrium. So that little distance would be 2a if you have a graph. And we said the period of these functions was 2 pi divided by b. So the amplitude, the a, gives us a vertical stretch or compression. It stretches our function up and down or compresses it down. And changing the period gives us a horizontal stretch or compression. It makes it stretch out horizontally, or it compresses it horizontally. So that's what the b does to our function. The b changes the period, and that's a horizontal stretch or compression. Amplitude, the a is a vertical stretch or compression. The period is a horizontal stretch or compression. And my hint was to figure out these graphs, to figure out important points. You divide the period into 4 equal parts. And figure out a y value for each of those quarter period parts. So we start at 0 and move in quarter period intervals, and look at the x value there, plug that into our function to find our y value. And those are going to give us our important points, our maximum, our minimum, and our intercepts. So we're going to continue with this as we get more complicated with the transformations we're doing with our function. So questions on the recap. Everybody good with this part so far? All right. So now we're going to get a little, make the transformations a little more complicated. So we're going to translate sine and cosine. And by translate, I mean shift them left and right, or shift them up and down. And the rules are the same as we've done with functions before. Just the fact that we have a periodic function makes it a little, just gives us another little twist. So when we're talking about translations, we'll talk about a horizontal translation first. When we're talking about a horizontal translation, we have a function y equals a sine, just like we did before, but now we're going to have a bx minus c. And if we have a cosine function, y equals a cosine bx minus c. So these are going to give a horizontal translation. The c is going to shift our function left or right, depending on whether c is positive or negative. Now when we have, the one thing to be careful with when we have a function in this form, before we look at the horizontal translation, I want the b to be multiplying in front of the parentheses. So before we start work, if your function looks like this, we want to factor the b out of this parentheses. So first step is to factor the b out. So I'm going to rewrite these as y equals a sine, and I want the b out here. And I factor that b out, so I get bx minus c over b. And when I factor b out of here, I have to divide it by b. And for the cosine, I would have y equals cosine b times x minus c over b. And once we have our function in this form, the shift is c over b units. That's going to shift our function left or right by c over b units. And depending on whether c is positive or negative, tells me if I shift right or left. Our period is still 2 pi over b. The period of these functions is still 2 pi over b. But because we're shifting left or right, our period is going to start shifted over left or right from 0, where our sine or cosine, where we normally start graphing our sine and cosine function. So one period is going to go from since we're shifted, one period is going to go from bx minus c equals 0 I'm looking up here at this original one, bx minus c equals 0, to bx minus c equals 2 pi. So I'm thinking of this whole thing in here as my angle. When the angle changes from 0 to 2 pi, my function is going to go through one period. So the period is still 2 pi over b units, but our period starts at bx, where bx minus c equals 0, and it goes to where bx minus c equals 2 pi. That's how we accommodate our shift. So let's look at an example of a shifted cosine function. So the only difference here between what we've done here from Friday is now we're shifting our function left or right. So let's look at, we want to sketch y equals cosine x minus pi over 2. So let's identify all of our numbers here. What is a in this function?
1.
A is 1. Our amplitude is 1. What is b? B is 1. We're out here in front of the x or out here in front of the parentheses. There's no number, so b is just 1. We're multiplying everything by 1. So our period is 2 pi over b, or 2 pi divided by 1. So our period is still 2 pi. And what is our c for this function? C is pi over 2. So I'm shifting this cosine function which direction by pi over 2? When I subtract, I shift right. So this tells me I've shifted right by pi over 2. So I can go about graphing this a couple of different ways. I can think about where our cosine function normally starts. We normally start graphing our cosine function at x equals 0, and it goes through a period in 2 pi units. I could shift that over to the right by pi over 2 and just do the entire graph shifted right by pi over 2. Once you get more comfortable with graphing these, you'll be able to do that more easily. Let me show you the step-by-step way so that we see this process. So our period is 2 pi. We're going to shift by pi over 2 units. And we're going to divide our period into 4 pieces. So my period is 2 pi, so 2 pi divided by 4 is pi over 2. And I'm going to start my graph where x minus pi over 2 equals 0, where this thing in the parentheses equals 0. So this tells me that x equals pi over 2. And my period is going to finish I'm going to end one period where x minus pi over 2 equals 2 pi. So I have x equals 2 pi plus pi over 2, or x equals, I need a common denominator to add here. 2 pi is 4 pi over 2 plus pi over 2 is 5 pi over 2. So my graph is going to go, one cycle of my graph is going to go from pi over 2 to 5 pi over 2. And I'm going to divide it, I divided my period into 4 equal pieces, so I'm going to go by pi over 2 units. So here's I'll sketch my axes for my graph. And my sketch doesn't have to be beautiful and perfect. We're just sketching. So I'm starting here at pi over 2. And I'm going over by pi over, I'm going to move to the right by pi over 2 units. Pi over 2 plus pi over 2 is what? Pi. 1/2 plus 1/2 is 1, so I just end up with pi. Pi plus pi over 2? 3 pi over 2. 3 pi over 2 plus pi over 2 is 2 pi, and 2 pi plus pi over 2 we already decided is 5 pi over 2. So those are my units. So I'm going to plug each of these points into my function to get a point to graph. So I'm going to plug each of these x values into my function to get a point to graph. So let's start at pi over 2. If x equals pi over 2, I get the cosine of pi over 2 minus pi over 2, or the cosine of 0. What's the cosine of 0? From our unit circle, cosine of 0 is 1. So here's 1, here's -1. So here at pi over 2, x is going to be 1. So I'm just plugging these points into my function. Now I'm going to plug x equals pi here. That's my next point. Pi minus pi over 2. 1 minus 1/2. Pi over 2. Cosine of pi over 2 is, I'm up here on my unit circle, straight up and down. X coordinate on the y-axis, 0. So there's my next point. Now let's think about what cosine function does. I start at 1, I go to 0. Where's my next point going to take me? -1. I could plug that into my function to see that. I could say x equals 3 pi over 2 minus pi over 2. 3 pi over 2 minus pi over 2 is 3 pi minus 3 pi over 2 minus pi over 2 is pi. Cosine of pi is -1. I go to -1, where am I going to go next? Thinking about how cosine works on the unit circle. I go from 1 to 0 to -1 to 0 again. And then from 0 I'm going to go to where? 1. So here's one cycle of my shifted cosine function. And if I wanted another cycle, I could go by pi over 2 units, and my cosine function would keep going like this, and I would keep adding pi over 2 units. So I've just shifted my cosine function over by pi over 2 units to the right. Does that procedure make sense? How I picked out my points and how I plotted those points? Anybody shaky on how we're doing that? Let's look at one that is a little more complicated. We have y equals 2 sine 2x plus pi over 2. So what do I need to do to this one first? I need to bring this b out in front. So I'm going to factor this 2 out of the parentheses here. So I'm going to rewrite this as y equals 2 sine 2 times x plus what? Pi over 4. I'm dividing pi over 2 by 2, so I get pi over 4. So let's write our numbers here. What is A? What is our amplitude? A is 2. B is 2. So our period is 2 pi over 2, or pi. So our period is pi. And C is pi over 4. So I'm shifting over by pi over 4. My amplitude is going to be 2, and my period is going to be pi. So I'm going to divide my period into 4 pieces. So I'm going to say period over 4 is pi over 4. So I'm going to look at every pi over 4 units, and I'm going to start my graph at 2x plus pi over 2, where that equals 0. So I'm going to start where this equals 0. This tells me that 2x equals minus pi over 2 divided by 2, or x equals minus pi over 4. So I'm going to start my graph at minus pi over 4. I'm going to finish my graph, finish one period, at where this thing in the parentheses equals 2 pi. 2x plus pi over 2 equals 2 pi. So 2x equals 2 pi minus pi over 2. X minus pi over 2 is what? Find a common denominator. So this is 4 pi over 2 minus pi over 2. So 2x equals 3 pi over 2 divided by 2. So x equals 3 pi over 4. So I'm going to do one period of my graph from x equals minus pi over 4 to 3 pi over 4. So let me sketch. And we're just sketching. We don't have to make a nice, beautiful graph. So here's minus pi over 4, and I'm going to move to the right by pi over 4 units. So here's 1 point, pi over 4. I move to the right by pi over 4. I end up here at 0. Move over another pi over 4. I end up at pi over 4. I move one more pi over 4. Pi over 4 plus pi over 4 is what? 1/4 plus 1/4 is
Pi over 2.
2 pi over 4, or pi over 2. And finally, my last point, if I add pi over 2 plus pi over 4, I end up at 3 pi over 4. And that's where I'm stopping. That will give me one full period. And I'm just going to plug these points into my function now.
Hi, can I borrow Harrison real quick?
Sure. So I'm going to start by plugging in minus pi over 4 in here to my function. So I'm going to plug in x, so minus pi over 4. Let me write those out because it gets kind of complicated. So I'm going to say y equals, my function is 2 sine 2x plus pi over 2. And I'm plugging each of these points in here. So y, my first point is y equals 2 sine of 2 times negative pi over 4 plus pi over 2. So I get y equals 2 sine 2 times negative pi over 4 is negative 2 pi over 4, or negative pi over 2 plus pi over 2, which is y equals 2 times the sine of 0. What's the sine of 0? 0. So I start here at 0, and we know the pattern, right? What's my amplitude, did we say? 2. So my maximum is going to be 2, and my minimum is going to be negative 2. So I'm going to go up 2 and down 2. So this is 2 and negative 2. So from 0, sine goes up, So what's my next point going to be? I start at 0 and I go up to 2. And from a maximum, I'm going to go to where? Back down to 0. From 0, I'm going to go to a minimum down here at -2. And then back up here to 0. And I can check these, I could plug all of these points into my function to calculate them. But once we're familiar with how our function works, we can see that my graph is going to look not beautiful and perfect, but there's one period, and if we keep going by pi over 4 units, it would continue. If we wanted to do another period, we can just keep going by pi over 4 units. And that would be a very rough sketch of my graph. Questions on that? So if we find our numbers, A, B, and C, divide our period into 4 pieces, start our period where this equals 0, end our period where our parentheses equals 2 pi, we can find our critical points, our interesting points, and sketch a plot of our graph. I'm going to talk about one last thing. I'm not going to do an example from these because it gets kind of repetitive. This next one is just, I want to tell you how a vertical shift, what a vertical shift looks like. So if we have a vertical translation, so a vertical translation, this is going to be our most general form of our function. Y equals D plus A sine bx plus c, or y equals D plus A cosine bx plus c. The D gives us a vertical shift up or down. We shift up, D units if D is greater than 0, and we shift down D units if D is less than 0. So this just shifts our graph up or down. Everything else stays the same. Our amplitude, our period, the way we divide our period into 4 pieces, the way we figure out how to plot our points. But instead of starting on the x-axis, I move up D units and graph my function up or down D units. Everything we did with the period and the shift, everything else stays the same. I'm just moving the whole thing up or down by D units. If D is positive, I shift up. If D is negative, I shift down. Everything else stays exactly the same. I'm not going to go through a whole other graphing of this function, because all we're doing is taking everything we know and moving it up or down by D units. And our amplitude then tells us not how far up or down above 0 we go, but we start at D, whatever D is, say D is 5. We shift up 5 units, and our amplitude tells us how far up above that line and how far down below that line our function is going to go. We're just shifting up and down. Questions? So we'll have a couple of days to work with this, to work with sketching, and Friday we'll have kind of a big review session where we can practice sketching all of these different kinds of functions. So like I said, if it's not making total sense right now, I think the more you work with it, the more sense it makes, and sometimes it does take a little time to get just to get used to the process. All right, so homework. All right, there you go.